Hello friends, welcome everyone. My name is Zubair Altaf Qureshi and welcome to my channel Z Network Lessons. And today in this video I will be talking about the IPSec VPN, and that is a site-to-site VPN in your Checkpoint. So I'll be first of all explaining you what IPSec VPN is, and secondly we will be demonstrating this in my lab. So let's begin. What a site-to-site VPN is. So in site-to-site VPN, what you do is you have a kind of tunnel between two sites, and it's like a dedicated connection that you build virtually over the internet, right? Over an unsecured network. So what we do is we have say a firewall at one side, and this is the branch side, okay, and say this is the headquarters and this is the branch firewall, right? So headquarter and branch, right? So they need to communicate. Say for example the branch needs to speak to the headquarters, because the fact is that you have a server over there and this branch has to access this server, but this cannot be done over the this can be done over the internet, but the communication should be secured. So in that case what we do is we form a IPsec tunnel between these two firewalls, and that too is actually over the internet. So this is your internet, and you build a tunnel literally over the internet, which is encrypted, and so that nobody on the internet can peek into the data that we have or the traffic that we have and sniff or steal some important data that we don't want anybody to have, right? So that is the whole concept of site-to-site VPN. But in case of IPsec VPN, what we do is we have different modes and we have different packets. So you need to understand the modes and the packets and why we have those modes and what these modes mean. So first of all, we have the phase 1 and we have the phase 2. Okay, so the phase 1 is also called your IC. These are many versions, version 1, version 2, and this actually uses phase 1 uses your ISACAM, Internet Security Security Association Key Management Protocol, yeah, and it uses UDP 500 to communicate. So in the case that you have two routers forming a tunnel and you have a firewall in between, so you have to allow this UDP 500 for the phase 1, right? And also for the phase 2 it uses your ESP protocol, and it has its own protocol number, and that is your protocol 50. Okay, ASP provides you encryption, hashing, as well as authentication. Then there is another method, AH, authentication header. This uses protocol number 51, but generally we use ESP because AH only provides you authentication and hashing, no encryption. So it doesn't make any sense to use AH instead of ESP, because ESP provides you encryption, and that is the whole point of this VPN, right? So that is the two phases that you have, phase 1, phase 2, and these two phases have their own packets inside. So let's see what phase 1 means and what phase 2 means, right? Let me just clear this, and also let me clear this, and let's go to the next slide. Okay, so this is phase 1. What is defined in phase 1 is, you can remember by the word haggle. Haggle stands for hashing. The first thing that you define in phase 1 is your hashing. Then you have authentication. You have to define the type, the authentication type. Is it pre-shared or is it certificate based, RSA? Inside hashing you again have different options. So you would have your MD5 you would have your SHA, And SHA has again different flavors, SHA 256, SHA, like that. And then authentication, I told you already, pre-shared and your RSA. Then you have group, again that is your keying material, the session key. So DH is you have from group 2 5,7, like that. And then you have lifetime. The lifetime depends on the vendor. Some vendors, I mean, it changes from vendor to vendor. So as I see in Cisco, the default lifetime for the phase 1 is 24 hours, 86,000 some seconds. It's 6,400 seconds, I guess. Yeah. But in case of Checkpoint, it's different, and we'll see what it is, and you can change it. No worries. Then you have the encryption method. So here, what you can say is encryption method. Different methods you have. You have the DES. You have 3 DES, and you have AES, and then you have AES 256, like that. So higher the encryption power, obviously higher the resources it would consume from your device, right? So DES is around 56 bits, and like that, 3 DES multiplied by 56, like that. So that is your phase 1, and phase 1 you have to configure all these options, right? And next, let's move to your phase 2. Again, in phase 2, what you do is, okay, this is a phase 2, right? Phase 2 is also called your IPSec security association. Again, in phase 2, you have hashing. Again, you have the same options, MD5, SHA, lifetime. Again, we will see in Cisco by default 1 hour, and like that. And encryption, again you have DES, 3 DES, and all those stuff. And also you define the encryption domain. Now, or you can set the interesting traffic, right? You in Cisco routers, you use this with an ACL, right? You configure this with an ACL. So that is your domain. So this is what you define in your phase 2. IPSec, yeah. So IPSec full mesh. So we have different type of topology. So let me just clear this. Yeah. Okay. So let me grab this. So if you see a side to side is simple, right? One firewall and another firewall, and you build a tunnel in between, and that is your side to side, one side to one side, right? This is the tunnel, phase 1, phase 2 both. So this is your side to side. Now you have full mesh. In full mesh, what you do is you have multiple sides, like that, multiple branches. So now what you do is you build tunnel from, not this one, sorry, not like this. So how can I build? Yeah, how can, so you have a tunnel like this, which goes from this to this. Okay, then again you have a tunnel from here to here. Hope you understand, guys. So this is a tunnel, and again you have a tunnel from here to here, right? And again a tunnel from this branch to this branch. Now what you missed is this to this, so you again have to have a tunnel like this. So everybody has a tunnel with every other branch side, right? So this is your full mesh. You can see this guy has a tunnel with this branch and this branch and this branch. So one tunnel with this guy, one tunnel with this guy, one tunnel with this guy, right? Likewise, every other side will have 3 tunnels with their neighboring headquarters, or you can say branches, right? Like that, this guy also has like this with this, with this, and with this, and likewise this will have tunnel with this and this and this. So this is the way you can define the full mesh. So every site has connectivity with every other site. Okay, so this is your full mesh. And then you have the IPsec star topology. Let me just grab my, yeah, then you have the star topology. So star topology is like, you can say hub and spoke. Okay, there is a centralized site, and then all the branch sites connect to that centralized site. What is the difference between the IPsec, full mesh and star is that inside star you can write, I mean you can go with dynamic routing protocols, but inside your full mesh or your side to side you cannot go with your dynamic routing protocols. In fact, you don't have this option of to select the dynamic VPN routing, right? This one. So this is only available when you select the community as star. Okay guys, and star is like this only, that it has this shown in the picture there, one central site, and then you have the headquarters like this, like this, like this. Okay, then you have tunnels from there to the center like this. And if you want to talk to this guy, you have to go through the center like this. So you will be able to talk to, I mean say the site 1 will be able to talk to site 2, but then he has to go through the site 5, that is your the hub, right? So it has to go like that, like this, and everybody has to talk through the hub. So that is your star VPN, and star VPN has different options also. So you can see you can do I mean a topology where the satellite sites will have only I mean routing with the center, and then again you have an option to center and to other satellites through the center. So you can have a routing neighborship through the center from between 1 and 3 and 2 and 4 like that. And then you have last one, that is again the same through the center, but also you can reach the internet via the center. So center can be your DC, where all the sites are sending their internet traffic, and after processing the firewall policies and all, the I mean the hub actually directs your traffic to the internet. So all your sites have your internet reachability via your hub. So that is the last type that you can see. Okay, so let me just clear this all nice, and let's move to the next topic. So you have VPN introduction. In here I'll be discussing with you the different type of objects you have inside your this Checkpoint VPN. So first of all is VPN peers. So what do we call as VPN peers? So for example, I mean let me just draw my the topology that we will be having. So what we have is see, this is our headquarters firewall, this is our manager, this is the smart console, okay, and this is our branch firewall, and behind branch firewall I have a PC like this. Okay, let's connect them. So I have the connectivity like this and like this. So this is connected, okay, and then I have okay, I have a connectivity like this. Say this is connected to my firewall, this is connected to my PC, and this is connected to my manager. So let me just quickly write down the, so this is my PC1, I will say HQ, and this is my manager MGR, this is my firewall 1 HQ firewall. So I can say what HQ firewall, HQ FW, and this is my branch firewall BR FW, and this is my PC2. Okay, so this is PC2. So now that this will be connected via the internet. So I have the internet here, and this is connected to the internet, and again this other firewall is also connected to the internet. So I have an IP address here and here, right? So this whole range, internet range, I'll be simulating with my 192.168.1.0/24, and this this IP will be .111, right? And this IP would be .112 like that, right? All the IPs on this firewall 1 is .111 actually, okay, and all the IPs on this firewall 2 is .112 like that, okay. So this range is 10.2.2.0/24. So the inside IP of this firewall would be 10.2.2.112. Likewise, this PC here is .10. Okay, So the whole IP would be 10.2.2.10, right? And this side is the whole address is 10.1.1.0/24, and this one is your 110, and this is your 10.10. Okay, so hope you understood the whole design that we have in our lab, and we will be building a tunnel in between like this. Okay, so the VPN peers are nothing but the IP addresses on the external side of the firewall that we are going to use to form the VPN. So for branch firewall, the peer IP is .112, and for branch headquarters firewall, the peer IP is 111. Okay, that is your peer IP, and then you have the VPN encryption domain. So encryption domain is the subnet that you want to encrypt. So for me, the subnet that I want to encrypt is this one, the whole subnet. Or you can take just one host, that is also possible. And in here I will take this 10.2.2.10.20 whole subnet. Okay, so whenever my firewall, anybody inside this 10.1.1.1 wants to reach, so say for example 10, okay, let me just undo this, okay, and grab the text. So say for example 10.1.1.1.10 is trying to reach 10.2.2.2.10, right? So when this packet reaches the firewall, what firewall is going to do is it's going to check the routing table, right? And whenever it checks the routing table, it sees that there is an VPN applied to it, right? The policy, it's there, and it says you have to send it through the VPN, right? So it will encrypt this traffic, and it will encapsulate actually on the public IP address. So it will be encapsulated. So you will see this as .111 talking to your .112. Once this reaches the firewall 2, right, the branch firewall 2, it will have the decryption key, right, that is required to decrypt this packet. Once it decrypts the packet, it sees that the packet is actually for 10.2.2.10, and it checks the routing table and it forwards it to the 10.2.2.10 inside. But before that, obviously you will have policies that will be checked. We have to create those policies, and I'll show you that and that thing. So hope you understood this encryption domain, right? In Cisco we use this as an ACL, but here you have to define, and I'll show you where you will be defining all this. Okay, and then you have the VPN community. So VPN community is the most important thing. So inside VPN community, it is like an object, and inside VPN community you define the VPN peers, you define the type of topology you are going to have, you define the encryption domain, you define phase 1 proposal, you define phase 2 proposal. Everything is defined inside this VPN community. Okay, this is your VPN community, which has lots of information. Every information, if you see, it's inside the VPN. So this is the most important object in your VPN part of your checkpoint. Okay, so next is let me just undo this, guys. Yeah, so next would be your okay, wait a second. Okay, let's move on to the next slide, and this is your understanding the IPSec packets. Okay, this is the best thing. If you learn this, it will be easy for you to troubleshoot any IPSec VPN issues. Okay, so let's go with this. So you have two modes in phase 1 and phase 2. Let me just again grab my pen. Okay, I have the notepad here and I have pen. So what we do here is this is your phase 1, right? So let me write down phase 1. This is also called what main mode, mm. Okay, we will see as mm in the inside the VPN. So we have packet 6 packets inside this if you are running the normal mode, not the aggressive mode. Okay, you have packet 1, 2, 3, 4, 5 and 6. So packet 1 is actually your proposal. Okay, so this is your proposal from one side. So proposal consists of all the things, right? The encryption, the hashing, the lifetime, the DH key, all those things. So this will be from say the initiator to the peer, and then you have again the peer responding with his proposal. Okay, but one thing to remember, that when the initiator sends the proposal, it sends all the proposal that has been configured on the on that side, on the initiator. So you might see tens of proposals being sent to the peer, right? But peer will reply with one proposal back, the one it selects that matches. Okay, and then you have the third one. So inside you have the DH key going to and fro your peer. So this is the DH key. Okay, and then I mean here you will never see any problem. I mean, because this is automated, and DH you don't have any control on the DH unless you don't, I mean you don't misconfigure the DH. So in the first 2 packets, if the proposal is not matched, then you will be facing problems in there, and you have to see that the proposals are matching. And the 5th one is for your the key, the authentication key. So authentication key is exchanged here. Okay, so authentication key is exchanged on, I mean both side will exchange the authentication key. So any misconfiguration with the key will result in failure in packets from 5 to 6. Okay, so that is the phase 1. Now you have phase 2, right? So let me just see the PowerPoint. Okay, check VPN proposal, encryption hash life, response from the peer, obviously, DH key, and yeah, announce is sent in DH key, obviously. So announce is nothing but it's a garbage value which will be used to check the DH key. So when the initiator sends the announce, it will be encrypted, and the other side will be decrypting using the exchange the key, and if it's successful in decrypting, that means the DH is successful, right? So that is why the nonce is used. And also until here all the packets will be open. Okay, so until here it is not encrypted. You can see this clear, what proposals you are sending, what proposals you are receiving. It's clear over the internet. But once you have the DH, then this 5 and 6 will be encrypted, because this is the most important part, because this will share the authentication key, and if the authentication key is compromised, then the security is compromised, right? So from packet 5 and 6 the encryption will begin. And let's move to the quick mode, and the next mode is quick mode. Again, you will have 3 packets in this. Total 9 packets are there. So from 7, 8 and 9 is your quick mode, and from 7, 8 and 9, the 7th packet will be the the proposal for phase 2, and also it will agree on the encryption methods, right? And the what do you say, the ACL and all. So that is if you are facing any issues here, so you now know where you have to look for. You have to look for the proposal in phase 2, right? And the final is an acknowledgement. You will never face any, if you face an issue there, so you have to again check the proposals. Okay, so that was phase 1, phase 2, and the explanation of phase 1, phase 2. And this is the troubleshooting. We will do it when we will do the lab. Okay, so this is it for the video, guys. I will have a new video, because this is getting longer than what I expected. So I'll create a new video for the lab, and kindly stay tuned for the next video. And please don't forget to subscribe to my channel, share my videos, and like my videos. Thank you guys. Bye bye.